Hello guys, welcome to my channel. This time we're going to be talking about an equal series of payments as opposed to what you have to pay in a geometric series of payments and an arithmetic series of payments and following the equations that you see on your screen. But basically what we're going to be talking about here is try to decide which one's going to be better in one way or in certain circumstances over another circumstances. um, yeah, well, so for that we need to build the amortization tables or the payment schedule for each one of them, and this is what we're going to be doing. As always, I'm going to be loading this to my coffee site, and if you want to buy me a coffee, I'll be very glad and very thankful for your support to this channel and to what I'm doing. So thank you in advance for that. Please share this video and drop a like if you like this content, and maybe you can share it with someone that you think you're gonna be it's gonna find that useful. So let's just go ahead and start. So for the period, let's just start off by 1. We're going to be using the same formula for everything, so we're going to be copying and pasting it all over the amortization table. So remember that we did before this one, if that value above equals to nothing, then type nothing. If not, if the value above is less than the years times the periodicity. We're gonna be looking this up real quick. Let me just go ahead and show you F4 using F4, so you get the money sign front and before the letter. Okay, then just go ahead and use this one plus 1, or else just go and type nothing. Let's see if that worked. Okay, it should be working until 144. Yeah, let me just go ahead and go like do some exaggerated here, and I'll go to 500. All right, so let's see, let's do something a little bit less problematic so we can see if it works. Yes, so 1 year and periodicity, which is going to be 12 months. Yeah, okay, this time we're not going to be talking about, let's see, yeah, 12. Yeah, this is working. Okay, this time we're not going to be including additional payments, because this is like messy enough. So we're just going to be dealing with the problems here. Okay, so I'm just missing here the payment. I'm just gonna put the payment over here, and I'm gonna link it. All right, so let's start. So first, at least we have one period, right? The first one in an amortization table. So this times your rate, and we're gonna be looking this up, divided by the periodicity. So it means that you're gonna be paying every month. Yeah, and the payment, that's gonna be the thing over here that we're gonna be looking this up. And I think I'm gonna look it up so I can like drag it down and stuff. It's not gonna work, but okay, let's just go ahead and do this. Okay, so the payment minus the interest payment, that's the payment to the principal, and then the final balance, that's just going to be the initial balance minus the payment to principal. So now if this value equals nothing, then nothing. Not if not, just go ahead and get that one. Yeah, because the initial balance of year 2 is gonna be the final balance of year 1, right? And then we're gonna be doing the same stuff over here. So if this one's blank, if this value is blank here, so here, then leave it blank. If not, just this times the interest rate divided by the periodicity. We're gonna be looking that up too. It's gonna take a little while here, just for a second, but believe me, it's gonna be worth it. So for the payment, you do exactly the same. If that value equals to nothing or blank, you type nothing. If not, then the one above, right? Yeah, and the payment to the principal, exactly the same formula. If that value equals to blank, then leave it blank. If not, do the payment minus the interest expense. Close that, then your initial balance minus your principal. All right, then. Okay, so we're ready to look it up. Yeah, and this is what happens if we don't go like do this, the if stuff. Yeah, so if that value equals to blank, then leave it blank. If not, yeah, that. We just double click it. There you have it. Okay, great. Okay, so now I'm gonna be finding out what's gonna be the payment here. So PMT and the rate divided by the periodicity, the number of periods, which are the number of years times the periodicity, times minus the initial amount, and then you have it. And if you change that to 2 years, well, you know it's right, it's correct, because it ends up in 0. So the final value is 0 if you take 3 years, and so on and so forth, right? So let's leave it just for 1 year, so we can like see what we're going to be doing next now here. Okay, so if we take a look at the present value of this geometric series of payments, or gradient, whatever you want to call it, you see that there is an initial payment which is A1, and that's the one that we're going to be calculating that to. Okay, so let's start off with this 0, with 0 here, which G being 0. Okay, so we're going to be like, in our heads, we're going to be solving for A1. So this means that I minus G, it's going to be multiplying the present value and then divide this expression to that. So let's start. Okay, so the present value, that's going to be your payment, and then you're going to be multiplying this by your interest rate divided by the periodicity minus the growth rate, right? And then we divide that by 1 minus, and then we open 2 parentheses here, 1 plus G, right, divided by 1 plus I, which is 12% divided by 12. And then we close both, and we take that to the n power, and that n power is going to be the years times the periodicity. Don't worry about this. If you go to my coffee site, you're going to be able to download this, so you don't have to worry about all this formulation. And as you can see, if the gradient is 0, if the growth rate is 0, we're supposed to be getting the same value as the equal payment part here. So yeah, so those two okay, so the first three columns are gonna be just the same, so we're gonna be copy this out, G, right? Now let's see what changes. Okay, so we start off with this value, and then the payment, that's gonna be our first value here, right? And then for the next payment, we're gonna be using this very value, and then plus 1 plus g. Ouch. Oh, yeah, that would. And we're gonna be locking that cell. And then remember to do the if function, right? So it just doesn't go crazy if it finds a blank space. So yeah, all right. Then we double click it and take it to the very end, and I think these two are gonna be just the same. So I'm just gonna be copying that out and pasting it over here. Let's see if it works. Yeah, and the formula went through perfectly. Okay, great. Now let's put this to the test. Oh, whoa. Oh. What happened? Payment to principal. All right, so if we turn that in, okay, so this is not supposed to be 1% because this is gonna be different. Okay, so it gotta be higher or lower than 1% because the 12% divided by 12, that's gonna get you 1%, and if you use 1% here, you're gonna get a big error over here. So you can use 1.1% if you want, or you can use 0.5% if you want, but you cannot use 1% as a growth rate. If you want to, get close to that, so just go ahead and go 0, 0, 0, 0, and then a 1 at the very end, and then you can get a number that is close with what you want. But that's kind of like a math cheating part. So okay, so let's leave it like that. And I'm gonna be formulating the last one. Okay, so for the last one, I'm gonna be using the same two. I'm gonna be using this first. Okay, so for the first part, that's gonna be the discount factor, and the discount factor is just 1 plus I to the n minus 1 over 1 plus I to the n, because we're gonna be solving for a. That's what we're gonna be using for a. So I'm gonna be let's put this a little bigger here. So see how it repeats here and here. This is what I would call the factor, the discount factor, and this is what we're gonna be calling PV to n. So that's gonna be the present value to n, if that makes sense. And so G over I, that's pretty straightforward, and G, it's gonna be the amount of money that you're gonna be increasing your payments into for the next period, and so on and so forth. And A, that's gonna be the payment, the initial payment for that one. So let's start off with the first formula. I think I'm gonna have to like this, so I can see what I'm gonna be doing here. Okay, so open to 1 plus, and this is gonna be the interest rate divided by the periodicity to the this times the years. It's gonna be minus 1, close the parenthesis here, divided by, open parenthesis, the rate divided by the periodicity times 1 plus rate divided by periodicity to the years times periodicity. Okay, I think, whatever, that might be, let's see if I got it right. Minus 1, yes, divided by the interest rate. yeah, times 1 plus G. Yeah, I got that correct. Now the present value for that one, that's gonna be, well, close that. This the periodicity times the years divided by 1 plus I divided by 12. This can perfectly be one of those videos, you know, to get you sleeping, right? Yeah. All right. Now, let's say that this is 1. Let's say that G over I, that's 1 divided by the rate divided by 12, periodicity. So we're gonna be using yeah, okay, so A, that's gonna be, so A, it's gonna be, okay, let's see how are we gonna be solving this out. So present value minus all this stuff, right, and then divided by the discount factor. So the present value, okay, let's open up a parenthesis here, this minus G over I, this times the discount factor minus the present value of n, and we close that, both of them, divided by, that's gonna be the discount factor here. Yeah. All right, now we know it's okay because yeah, well, it varies very, very little, and if you go like 0, this should be matching the present, you know, the payment, the payments, okay, so the equal payments amortization table. So let's leave it this right over here. Let me just yeah, let's just go ahead and select that, the first three, and paste it over here so we don't have to type that again. Yeah, problem with that one. Okay, now for the payment, the first payment, that's gonna be A, and then you're gonna be adding this progressively to the G, right? So that plus G, that double click, oh, sorry, I forgot to lock it. Yes, so double click it right here. Okay, now the payment to principal, so for that we're gonna be using the same formulas that we did before. And remember that we have to, you know, do the if formula again here, so it doesn't go like to the very end. This one equals nothing, then nothing, if not, then do the operation. All right, double click it, and there you have it. Okay, great. So let's do some additional stuff here, and just include the interest as some. I know a lot of people, it's gonna be you know, the period, the finance specialists, especially that I'm not considering the time value of money, but you know, this is one way to put stuff so you can, you know, see what's best, what works best for you. So interest sum. So let me see how much you're gonna be paying for interest here. Everything here. So let me just go ahead and copy this and put it over here. Okay, great. So let's assume something close to 1% as an increase, and here let's think about $1. So everything is pretty equals, right? Everything's everything's the same. You can hardly tell the difference between the three of them if you have this until 1 year, for 1 year. Uh, but this is substantially lower if you increase your payments by 1%. But your first payment is gonna be 93,775. So this is why, because you have a big initial payment. Okay, so let's see what happens if you include that to B2. So as you can see, this is still the winning horse, and now the payment's gonna be lower. The first payment's gonna be lower for the geometric series of payments, even though this is pretty hard, on your wallet later, and this is why you're paying a lot less interest. But let's change that to 0.5 and see what happens. If you change that to 0.5, that's gonna be the losing horse, and that kind of like tells the same story. But it takes a lot of time until you get to pay what you pay for the other two options, right? But so that's the first difference. So you got to play with this. Let's say, for example, that you're planning to pay for I don't know, a car. So let's say 5 years. It goes all the way to 60. So you pay $334,000 for a $1 million car. Well, yeah. Well, for $1 million, you're borrowing for 5 years. If you were to pay equal payments every month, and if you were like increasing by 0.5, you're gonna be paying $354,000 in total. That's gonna be a pretty good deal because after all, $20,000 in your company, you're gonna be turning that money into, well, yeah, at the first stages you're gonna be paying a lot less than what you'll be paying for the other two options. Well, yeah, you're gonna be releasing some. You can use that money, in your own company that's supposed to be providing more than 12% per year, right? So now let's go ahead and take a look at the arithmetic one. Let's say that you're gonna be adding $10 to the payment every year. So you start off with $21,000, pretty close to the equal payments. Then you pay $36,447 in interest in total for 5 years, as opposed to $334,667. But this is something that you can just go ahead and play with it and see what the problem here, what effect does it have in your your finances. In 1 year, this is not gonna make much difference if you have this setup, like 0.5 increase every month or $10 every month for 1 million, for every million. But as time goes by, as you increase the time frame, you see how you increase your payments too, your interest payments too. So if you turn that into 5, now you can see some difference here. I'm gonna be like doing $100 increase, perhaps. Yeah, maybe. So it's equivalent. Yeah. Yeah. So the larger the time frame, the more evident the interest payments are gonna be to your account. But if you turn that into, like, say, for example, 20 years, well, let's put 10 years, you can see. So I don't have to change the setup here. You can see some some difference here. I mean, if this is in dollars, you can like, this is very important. Okay, so yeah, I suppose that's it for today. Don't forget to drop a like, and don't forget that I'm gonna be leaving this in my coffee site, so you can just go ahead and um, you know, support the channel. Thank you very much for watching. Thank you for staying to the end. Bye bye.
몰라全てが幻舐めたきゃ舐めとけ代わりにゲロ吐く I have to go and boom boom Let's go, let's go どこへ Who's gone, who's gone どこへガタガタまた吠えてる Motherfucker 相手にできない夢から覚めない夢覚めないいつからこの性格 I don't mind ならば来れば自分がなけりゃ流される津波ミサミサミクサミクサお前のせいでレベラレベラフォロワーフォロワーやっぱりお前のおかげで右見て左見て右見てほら全てが幻舐めたきゃ舐めとけ代わりにゲロ吐く I have to go and boom boom Let's go, let's go どこへ Who's gone, who's gone どこへガタガタまた吠えてる Motherfucker 相手にできない迷える子羊たくさん目に間にそれでも懲りずに貫くべきかね本だ